Okay, welcome to this class. We will discuss about some of the experiments which have actually proved that nucleic acids convey genetic information. So the objective of this class is a little bit different. It's about how we should think, or its borders on research aptitude, the ability to formulate a question and then formulate a procedure or methodology to get the required information. So in the last class or before, I must have told you about the scientific method. The scientific method is very simple in the sense that all we need to know is to be, the first thing is to be curious. Yes, and curiosity actually comes from observation. Observation comes from some kind of perceptions, right? I mean, if one is, again, this is kind of circular. So if you're keeping your eyes open, that is building something, and then you will notice different things. Like we saw the four monkeys hugging, right? A picture of it, which we have discussed a little bit. And if this is the observation, then we will ponder upon why is that it is like that? Why not in a different way? And that is where your curiosity, which is the true drive for acquisition of information or knowledge. And knowledge eventually turns into, when you apply its intelligence, which will allow you to gain more knowledge, and eventually we'll become wise, or we'll attain more and more wisdom. So it all starts with, as a child, we are born, we are curious about everything. We observe a lot of things that are in our surroundings. We pick it up. And then this baby here is formulating a hypothesis. Hypothesis is something like A equal to B. And either it could be yes, or it could be no, or in other ways, it could be true or it could be false. So a hypothesis is a tentative statement made which would prove, which when proved or disproved will give us some information about a question. So here is an observation. This baby is trying to see what is it, and then it thought the baby is going to think, okay, baby is saying the object is food. Okay. And then the next one is to perform experiment. Easiest way is to put it in your mouth, and taste it and see if it is good or bad. Typically, if it is bad, we know that it is distasteful. And then we analyze how it feels because we ate, and it brings us nausea, or it's too spicy or something. It's not sweet, for example. And then you will have a reaction to it as a baby, or we, as an adult or a scientist, we report the findings by, if we knew the language and the way to present it, we would have reported it accurately. Otherwise, just a mere action of crying for the baby would have resulted. And it doesn't stop there. We give or invite other people to test the way we have, or the knowledge that we have generated. In this case, the baby has generated the knowledge that this particular object is not a tasteful food. And then we give it to others, or we invite others to test and see if the conclusion that we came up is right or wrong. Okay. That is about, we have to observe, make a hypothesis, perform the experiment, analyze the data, whatever you got, and then report the findings. And one should be open to others testing our information. And that is what is important for science. In science, the clear path to science is about doubt, not belief. Doubt in the sense you are allowed to, and nobody is going to object you. you are allowed to doubt anything in science, right? If DNA is the genetic material, you can doubt it. You can doubt it, but you should be able to do some experiment or something, or read up on many other papers, and come to a conclusion in a very honest way. Nobody is going to be penalized for doubting anything in science. Actually, doubting is the way of doing a science. Typically, if you find a hypothesis, you will consider, if it's more likely that A is, if it is seemingly A equal to B, then your hypothesis could be something like you want to disprove that A is equal to B, right? You're taking an opposite stance. Yes. So another simple example is, here is a woman, and there is a torchlight, and the torchlight is not working. And that's the observation that is made. And now you have to have, there are many components in the torchlight. You have the switch, there is a bulb, right? And there are batteries. Okay, so there are three components which could have been a problem. And then the question one is, in at least we'll just consider the most obvious problems that happen are about whether they are dead batteries or is it burnt out bulb. So if you, then you have a hypothesis here. Hypothesis one is the batteries are dead. Then you replace the batteries and you'll test and you'll turn it on and see. And the torchlight does not light up, which would mean that our hypothesis is wrong. That means batteries are not dead. That's the most likely one. And in hypothesis two, bulb is burnt. And then you predict, you try to replace the bulb and check what has happened. And then if it turns on, that means this hypothesis is right. In the When the torchlight did not light up, it was because of a burnt out bulb. To question yourselves, or some people may be having a question, what is the hypothesis? What is the hypothesis? What is the hypothesis? Hello, everyone. If you can hear me, what I'll do is I will record a video and I'll upload it today or tomorrow. Is that information audible?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now you can go ahead and do your other works. Maybe I think it won't be solved now. So I'll try to record one and I will post it. You please watch it today. Okay.
Okay, sir.
Okay, sir.
Yes. Thank you. Sorry for the
Thank you,
problem.
sir.
It's okay, sir. It's okay, sir. Thank you, sir.
Have fun. Bye.
Thank you, sir.
Thank you, sir.
Thank
It's
you,
okay,
sir.
sir. Thank you, sir.